Hello, students. I'm coming to you with the next video lecture on Chapter 1, Part 2. In the last video lecture, we discussed a number of concepts, including the difference between data and a data set, the difference between variables and constants, attributes of a variable, the difference between independent and dependent variables, and the difference between positive and negative relationships between variables. In this video, we will discuss various different types of analyses as well as various different types of variables. At the end of this video, I will invite you to check for your understanding of these concepts. In terms of learning objectives, by the end of this video, you should be able to understand and explain the difference between univariate, bivariate, and multivariate analyses. In addition, by the end of this video, you should also be able to understand and explain the different types of variables, which include dichotomous variables, categorical and continuous variables, and confounding variables. So let's begin by discussing types of analyses. In this segment, we will discuss three main types of analyses, which include univariate analysis, bivariate analysis, and multivariate analysis. Univariate analyses are intended to examine trends in the measurement of a single variable. In univariate analyses, there is only one variable of interest in the study. For example, in the research question, what are the trends in annual income last year among elderly ages 60 and older? There is only one variable of interest, which is annual income last year. Bivariate analyses use statistical tests to determine if there is statistical support for research hypotheses about the relationships between two variables only. So for example, in the research question, is there a statistically significant relationship between gender and levels of depression among the elderly ages 60 years and older? There are two main variables of interest, gender and depression. But keep in mind that although gender has two categories or attributes, this still counts as only one variable in the analysis. Multivariate analyses use statistical tests to determine if there is statistical support for research hypotheses about relationships between three or more variables. So for example, in the research question, is there a statistically significant relationship between gender, marital status, and depression among the elderly ages 60 years and older? There are three main variables of interest: gender, marital status, and depression. Here's a summary of all of the different types of analyses that we've discussed. Keep in mind that univariate analyses examine only one variable, uni meaning one. Bivariate analyses examine two variables, bi meaning two. And multivariate analyses examine more than two variables, multi meaning more than two or multiple. Now let's discuss types of variables. In this segment, we will discuss two different types of dichotomous variables, binary variables and dummy variables. We will also discuss the difference between categorical and continuous variables. And finally, we will discuss confounding variables. Let's begin by discussing the concept of dichotomous variable. A dichotomous variable is a variable which can take on only two values. Dichotomous variables can take on any coding system, not just 0 and 1, so long as there are only two categories. It is important that the researcher remembers how each variable was coded for interpretation purposes. This is where code books come in handy. Here are some examples of dichotomous variables. The first example is gender, which has two categories, male and female. The next one is social work major, which also has only two categories, yes and no. And finally, employed status also has only two categories, employed and unemployed. A binary variable is a special type of dichotomous variable. The term binary is often used in computing. It is a numerical system that expresses numbers using only two digits, 0 and 1. Often, binary data are used to represent two conceptually opposed values. Here are some examples of binary variables. The first one is home ownership, where 1 equals the presence of home ownership, or yes, and 0 equals the absence of home ownership, or no. The next example is the variable father in the home, where 0 equals the father's absence, or the father not being present in the home, and 1 equals the father's presence in the home. And finally, statistics course grade, where 0 equals a failing course grade, and 1 equals a passing course grade. A dummy variable is another special type of dichotomous variable. Unlike binary variables, dummy variables are created by the researcher and involve the manipulation of data for the purposes of analysis. Dummy variables are coded with binary values, which again are 0 and 1. So here's an example from my own work. In this study, I sought to understand those factors that best predict a father's involvement with his children. In my survey, I asked participants the following question: what is the status of your relationship with your child's mother? The original categories associated with this variable included married, widowed, and divorced. However, for the purposes of analysis, I manipulated the data in order to create a dummy variable. In this dummy variable, all of those who reported being either widowed or divorced were placed into one category, which I called not married. And all of those who reported being married were placed into another category, which I called married. This manipulation of the data left me with this variable to the right, which is a dummy variable. This is the variable that I included in my analysis. Now let's talk about the difference between categorical variables and continuous variables. A categorical variable is a variable that can take on a finite number of possible values. These types of variables are not quantifiable and have no mathematical meaning. The codes assigned to the categories are meaningless and are only used for the purposes of analysis. So I'm going to share with you two examples of categorical variables. One is level of education and the other is marital status. So if I were to ask participants on a survey, what is your level of education? This variable could be represented by these three categories, where 1 equals less than high school, 2 equals high school, and 3 equals college degree. In addition, if I were to ask respondents, what is your marital status? This variable could be represented by these three categories. 1 equals widowed, 2 equals married, and 3 equals divorced or separated. So the most important thing to keep in mind is that categorical variables are any variable that can be represented with categories or attributes. A continuous variable is a variable that can theoretically take on an infinite number of possible values. These types of variables are quantifiable and have mathematical meaning. So I'm going to share with you two different types of continuous variables. One is age and the other is income. So in this case, if I were to ask respondents, what is your age? And I were to ask them in this way, which is an open-ended question, this would allow respondents to simply write in their age. By asking respondents to write in their age, this kind of question would produce continuous data, which hypothetically, the age range could be from 0 to 100. This question could also be asked in another way, which would ask respondents to check a box next to the age range that represents their age. However, this is not what we want. In order to yield continuous data, we would have to ask the question in this way, which would allow for respondents to provide us with continuous data. The same is true for income. If we were to ask respondents, what is your income? And we allow respondents to write in their response, this would produce continuous data. However, this question could also be asked in a categorical manner by asking respondents to check a box next to the range of income that best represents their own. However, this is not what we want. In order to produce continuous data, we must ask the question in an open-ended fashion that would yield continuous data. Now let's discuss confounding variables. Confounding variables are unmeasured variables that are present in the environment that can impact the true relationship between the independent and dependent variable of interest. So essentially, confounding variables are any variable that can come in between the relationship between the independent and the dependent variable. Confounding variables are also referred to as extraneous variables or third variables. So these are often unmeasured variables that can influence this relationship. So for example, if we were interested in examining the relationship between activity level and weight gain, some of the potential confounding variables could be one's age, but it could also be levels of stress, diet, depression, and so on and so forth. There are a number of confounding variables that can influence the relationship between activity level and weight gain. But the thing to keep in mind about confounding variables is that they are unmeasured. These are variables that are not necessarily captured by the researcher in a research study. However, they can still influence the relationship between the independent and dependent variable. So in summary, we have discussed the difference between univariate, bivariate, and multivariate analyses. We have also discussed two types of dichotomous variables, binary variables and dummy variables. We have also discussed the difference between categorical and continuous variables. And finally, we discussed confounding variables. So now I'd like to offer you the opportunity to check for your understanding of these concepts. You can do this in one of three ways. You can either complete this survey on the left directly in your PowerPoint slide, or if for some reason you're unable to load or access this survey, you can also copy and paste this link into your browser, or you can scan this QR code in order to take the survey. I hope this has been helpful, and I look forward to seeing you in the next class.